A bus station has 12 times as many single-deck buses than it has double-decker buses. Determine the number of single-deck and double-decker buses if there are a total of 65 buses in the bus station. Let us begin our strategy for problem solving by analyzing the problem. Keep in mind that the first thing we want to do when analyzing the problem is identify the question that's being asked. In this case, we are to find the number of single-deck and double-decker buses. So now that we know what it is exactly we want to find, we know what our unknown variables are going to represent. So let us go ahead and jump to step 2 and assign a variable. We'll let x and y represent the following. X will be equal to the amount of single-deck buses, and y will be equal to the amount of double-decker buses. So now that we've assigned a variable, let us go back and analyze the problem. Well, based on the first line, we know that the bus station has 12 times as many single-deck buses than it has double-decker buses. And we also know, based on the last sentence, that there are a total of 65 buses in the bus station. So the keywords here being 12 times as many. So ideally all this means is we're going to multiply one of the variables by 12. And we also know that we have a total of 65 buses. So now a total of 65 buses, we could actually work with that one first. A total of 65 buses. Well, we know that there's an X amount of single-deck buses, and there's a Y amount of double-decker buses. So we add these together. That's going to give us the total number of buses, which should be equal to 65. So that's going to be our first equation. Now let us work with the 12 times as many sentence. So we're going to be working with the variables x, and we're going to be working with the variable y. Now 12 times as many, that means we're going to have to multiply either x by 12 or y by 12. Since it says that there's 12 times as many single-deck buses than it has double-decker buses, that means we're going to multiply the smaller of the two by 12. So there's more single-deck buses, which is represented by x, so we're going to have to multiply the y by 12 if we want these two to be equal. So again, since y is smaller, we have to multiply it by 12 to make the right-hand side bigger and equal to x. So now that we have both of our equations, I'm going to go ahead and write them down. And then we'll go ahead and begin solving our equations. Notice that in the second equation, the x variable is already completely isolated and by itself. So we know that x is equal to 12y. So what we're going to do is we're going to go ahead and substitute it in to the first equation. So we're going to end up with 12y in place of x plus y is equal to 65. And then combining the 12y plus the 11y is going to give us a 13y. It's equal to 65. And then from there, we're going to want to divide both sides by 13 in order to get the y completely by itself, since we're already multiplying it by 13. So the opposite of multiplication is division. So we divide both sides by 13. And on the left, we end up with our isolated y variable. And on the right, we end up with 5. So we now know that y is equal to 5. So now that we know what y is equal to, we're going to go ahead and substitute this back into the second equation. And we're going to end up with x is equal to 12 multiplied by 5. So then we end up with x is equal to 60. So now we have solved for both of the variables, so now let us go ahead and see our conclusion clearly. Since the question was determine the number of single-deck and double-decker buses, we'll state our conclusion as the following. There are 60 single-deck buses and 5 double-decker buses. So now that we've stated the conclusion, let us go ahead and check the result. We always start off by bringing down the original equation found in step 3. So we're going to have x plus y is equal to 65 for the first equation. And the second equation is x is equal to 12y. So now we're going to go ahead and plug in the corresponding values for x and y. And we know x is equal to 60 and y is equal to 5. So for the first equation, simplifying the left-hand side, we end up with 65 is equal to 65, which is indeed a true statement. So that verifies that our equation is correct. Now substituting in for the second equation, again we know x is equal to 60, and we know y is equal to 5. So we're going to substitute that in there, and we end up with 60 on the left just by bringing it down. Then 12 times 5 gives us a 60 on the right, which is again another true statement. So that verifies that both of our equations are correct. And our solutions for x and y are also correct.